So here's my definition for vertical asymptote. It says if R of x equals n of x over d of x is a rational function, and n and d do not have any common factors, then x equals a is a vertical asymptote of R where d of a is equal to 0. Let me explain all of this. I know it sounds like a different language, but let me explain. First of all, when you look at a rational function, it appears to look like a fraction. And we know a fraction contains two components, a numerator and a denominator. So the letters n and d represents numerator and denominator. N of x is the numerator's function, and d of x is the denominator's function. Okay? Now, as long as the numerator and denominator does not have any common factors at all, then x equals a is our vertical asymptote of the rational function. Now, the x equals a implies that when you plug a into your denominator's function, you're going to get 0. So essentially what we need to do in order to find that vertical asymptote, right, we're trying to figure out what's this. We're trying to find x equals a. To find x equals a, all you got to do is just set that denominator equal to 0. Like what we were doing earlier with finding the domain of rational functions. But there's just one exception. The numerator and denominator must not have any common factors. So let's look at a couple of examples, and then I'll do a couple more right after this. So when you want to find vertical asymptotes of a function, essentially, you write out your function in, or you simplify your function. You first write it out where they're both, where both the numerator and denominator is factored completely. If you look at f, the first one, part A, f of x equals 4x over x minus 2, 4x and x minus 2 does not have anything in common. So you can find your vertical asymptote of this function right away, right? Here, no common factors. So we find vertical asymptote by solving d of x, meaning the denominator, when it's set equal to 0, and you solve for x. If you take your denominator, which is x minus 2, and you set this equal to 0, what will you get? Careful. You get 2. You get x equals 2. So x equals 2 is our vertical asymptote. That's our VA. Let's try it again with part B. Part B, we have g of x equals x plus 2 over x squared plus x minus 6. Did I write this correctly? No, sorry, I didn't write this correctly. This should have been a minus x. My bad. Oopsie. It's okay. All right. So first of all, look at your numerator. Is the numerator already in factor form? Your numerator being x plus 2. Can you reduce that any further? X plus 2. No. X plus 2, right? The only thing that they have in common is 1, GCF-wise. So you cannot simplify that, right? But the denominator, you can't, right? So the numerator, we're going to leave it alone. If you look at the denominator is x squared minus x minus 6. So what are two numbers when you multiply them that gives you -6, but yet adds up to -1? Think of all the factors of 6. What are some factors of 6? Careful. There you go. You got it. -3 and +2. So your denominator will be x minus 3, x plus 2. Now look at this function here. When it's written in this factor form, do you have any common factors between the numerator and the denominator? x plus 2. The x plus 2's can be canceled out here, right? If you cancel out the x plus 2's, what you're going to have is 1 over x minus 3. And if you want to find the vertical asymptote pair for this example, all you got to do is just set the in the simplified form of g, just set that denominator equal to 0. Right? Now we take x minus 3, set that equal to 0, and we solve for x. X would equal to what value? X is equal to 3. So that's my vertical asymptote. Okay? So that's what my definition said earlier, is that if you do not have any common factors, all you got to do is just take the denominator, set it equal to 0, and solve for x. But as long as you don't have any common factors. But if you do have common factors, you got to remove them first to simplify your function. And then when you simplify your function, you can then find your vertical asymptote with what's remaining. All right. Let's try this again so that way we can get the hang of it. All right. Let's look at part C. Let's say if I give you part C, h of x is x squared minus 36 over x minus 6. In this example, you first want to write both numerator and denominator in factor form. Can I rewrite the numerator in factor form? X squared minus 36. Yeah. How would I rewrite the numerator?
X minus 6.
X plus 6, right? So x minus 6, x plus 6, because it's a difference of two perfect squares. And then you divide by x minus 6. Now look at this function in this factor form. Do you have anything in common?
X minus 6.
Yeah, you can remove the x minus 6. If I remove x minus 6, then our function h, when it's simplified, is simply going to be x plus 6. Now look at this function closely. When it's simplified, what type of function is this? It's a linear function. And what do we know about linear functions? What does this graph look like? A line. Do you think those lines are going to contain a vertical asymptote? No. Right? So for this function, we know that it's going to be a graph of a straight line because it's a linear function. We know that there's no vertical asymptotes. But there's just one other piece of information that I do want to mention. You see, this function does have a domain issue. Originally, when you look at h of x, the denominator was x minus 6. What happens when you plug in 6 for your x? What would be your denominator? 0. Can you divide by 0 in math? No. So ultimately, when these x minus 6 were being canceled, we just make a comment saying that x can never be equal to 6. And because x cannot be equal to 6, if I were to plug it into my simplified function, you do get a value, right? What's 6 plus 6? 12. So at the order pair 6 comma 12, you're going to have an open point, right? So here you're going to have an open point at x equals 6. And I could just show you a quick visual representation, right? Quick visual, not drawn to scale. As you probably know, my visuals do not come out very, very well. No matter what I do, I'm not a good artist. Here's the y-axis, here's our x-axis. So here's the origin. So for h of x equals x plus 6, we know that it has a y-intercept of 6. And we know that its slope is 1, so it's a line that should be increasing. So 1, 2, 3, 4, 5, 6. Here's my y-intercept. If I did plug in x equals 6, however, we're going to get an open point. That open point you're going to get is 12. So your graph will look something like this. can go through the close point, but bypasses the open point. All right. Let me talk about horizontal asymptotes with you, and then I'll show you how to graph them. Okay.